Hello, everyone, and welcome to C++ 101, an introduction. This is week number 3. And with that, let me go ahead and just hand it on over to Nelson so we can get started today.
Okay, so the first order of business is going to be talking finally about strings, which is going to be very exciting because as of yet, we haven't really talked about them, and it's going to be very important that people understand how to use them. I do want to point out, however, that strings they're non-trivial in C++, which is kind of why we put them off until now. But hopefully people will have a level of comfort that explaining strings should make a little bit more sense. We're also going to be talking a little bit about a C++ 11 feature, but I do want to really quickly point out that this feature is not supported in Visual Studio or Visual Studio 2010. It's only supported in 2011. So we're going to look at that, and we're going to look at how to get the GCC C++ compiler to work with the C++ 11 features. I don't mean Studio 11. I mean Visual Studio 2012. That's the correct one. So when we get to that, I am going to be jumping over to my Windows 8 VM. All right. So I'm going to go ahead and jump into Visual C++ 2010 Express, and we can go ahead and start talking about strings. And while this is starting, what kind of questions do people have so far? I mean, I guess that there is the open office hours, but if there are any quick questions that people might have at this point, that might prevent them from, well, following along with today's class.
If they used break in their homework, is that unacceptable?
Well, we are covering break today. So,
all right, I'll ask a sub-question. Is it any different from break in C#?
No.
In that case, that's fine, Mohammed. Just making sure that I understand what I see when I see it. You're welcome.
Now I can breathe.
A proper programmer, he breathes code. There's a question there from NATO as well, Nelson.
We haven't covered strings just yet, and we're going to cover them today. I guess that was a terrible spelling mistake there. That's up to Gavin at the end of this class, because really using strings is a little bit more complex than you might think. So I wouldn't have recommended people who are new to programming to attempt to use strings before we went over them, which we're going to be doing here today. But that's up to Gav, I think, as far as last week's homework.
Fabio also had a question for you up at the 310 spot in the questions panel. Nelson?
310...
309.
That'll probably be 109.
Oh, yeah,
How
good
do
point.
I make subtraction with float like this? 0.8 minus 0.2. Well,
you're not going to see it.
No, I'm not. I had to wait for it to build. C++ compilation does take a good while. Well, in this case, you're going to run into some rounding issues with floats because floats are a bit finicky, the way that floating point numbers work. Getting this particular subtraction example to work properly is going to be very difficult. So basically what we have here is a very, very small number. This is an incredibly small number. As you see, the exponent is going to be -8. So
What does that show? What does that show if you start with 2 instead of 1?
This should be a little bit closer to something that's reasonable. In the case you get 1. The actual rules about floating point precision are a little bit finicky, and they're going to be a bit of a pain to sort of get to work right. Once you start talking about really, really small numbers, and 0 happens to be a really, really small number.
See, my reading of that problem there was that because there was no leading non-zero digit initially, when you start off taking 1 minus, essentially 1 minus 1, you get 0.0000000, very small number. If you take 2 minus 1, you get 1 point, very, 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 very small number. But because you've got that leading one, that actually gets knocked off by the floating point error, and you're left with 1.
Yeah, well, it gets tricky, and the rules are, what's a not? I think he meant 0, right? Or, I don't know. Yeah, the rules get really tricky, and I wonder if we go ahead and change the type instead of a float to a double, if we can get some more, enough precision to properly represent the number that we're trying to present to the user, in which case it's 0. I'm getting some really nasty performance on my VM right now.
How many VMs have you got running?
Only 3. So in this case, we get more precision, but this is still an incredibly small number. As you see, it's again being the exponent is 17. So yeah, it's just a classic floating point issue, which leads to problems with comparing floats, which we can get into at some point. But I don't want to get too... Well, if you wanted to compare this to 0, you never compare floats with equality members, with the equality or inequality. Instead, what you do is you say something like, if 0 minus f is greater than, if it's in a particular range. So if 0 minus f is greater than 0.001 and is 0 minus f is smaller than negative 0.001. Typically, that's how you, or am I going backwards?
Yeah, you're going backwards.
Well, hold on, I have to wait a year. So at this point, what we're doing is we're comparing 0 against the floating point digit, and we're comparing the difference between what we expect and a range that we've specified. In this case, the acceptable range is going to be 3 zeros followed by a 1. All right, so let's go ahead and talk about strings for a little bit. So what a string is in C++ is really just an array of characters, meaning that if I were to say char my string that, this would be, and give it some, let's say 10, this would be a representation of a string in C++. We can fill it with data. We can say char my string 0 equals h, my string 1 equals I. And then at this point, what we will do is specify a null terminator at the end of what we have considered to be our string. So in this case, this is a null terminated string of h and I, followed by a terminating character. And if I were to print this out, you'll see that we get eventually, the proper result. So what all a string is in C++, at least as far as what are referred to as C-style strings or null-terminated strings they're just an array of characters that are terminated by a terminating character. In this case, the null-terminating character. If I did not have the null-terminating character right there, the array wouldn't know, or cout wouldn't know when to stop printing out this string. So you'll notice that I get, well, a bunch of garbage. So that's really all strings are in C++. And you can, there are ways to initialize or contain strings inside of a variable. Like, for example, if I were to do that, what we have here is basically a built-in conversion between a string literal and an array. And by not specifying the number inside of this array, the constant number inside of this array, what I've essentially done is kind of like implicit typing. I've instructed the compiler to construct an array that's big enough to store the data that I passed into the initializer. Now, I want to point out that this is not dynamic memory allocation. What this is essentially doing is it's nothing more than if I had literally stuck 11 inside of these square brackets and then initialized manually every single character into something.
The question that's come up in the question panel, why didn't the H and I show up without the Terminator?
My theory in that case,
because presumably the garbage that appears is just
right.
Whatever happens to be already in the memory that is now allotted to the char array.
Correct, and that is indeed what happens. But here's my theory. In this case, it did show up. My theory is that a particular control character inside of here, inside of the garbage memory, backed up and overwrote it. Because if you notice in my previous example, when I didn't have the null terminator there wasn't that high, but my keyboard cursor was in the middle of the string. If that makes sense. So
yeah.
Some sort of garbage control character resulted in it backing up and overwriting that during display. And the behavior is really undefined. Again, this is not something that is defined or should be relied on to perform any particular operation. You always want to use a null terminator because otherwise it doesn't know when to end the string.
But well, there's one more question tied to that, which is, does the char array still take up the size of 10 even if you terminate it?
Well, yes. If let's say I have a char array of 10 and then I terminate it on the third index with a null terminator, the amount of memory that's being allocated for this high string that's being printed out is still 10. So this array is still 10 characters long. It's just when it's sent to cout, what happens is a cout loops over every single item within the array until it finds the null terminator. If that makes sense.
Yeah.
So I am, like Segfault says, I am wasting 7 bytes in this case.
Essentially, as far as the char array is concerned, that's just another character. It's the cout that recognizes that and has specific behavior.
Right. And every other function that works with C-style strings. So, I mean, that's all cool. So let's talk a little bit about what is going on in this case. And again, the syntax that I'm throwing out here is just, it's not implicit typing, it's implicit counting. I don't know if it has a name. It probably does somewhere buried in the C++ specification. But what we're doing here is, by not specifying a number here, we're still allocating a static array that's allocated on the stack, not allocated dynamically. But because the C++ compiler has special knowledge of a C-style string, it will properly figure out that what number should go in here. And you see if I hover over it, Visual C++ is telling me that it's an 11 character long string.
So it actually automatically generates a terminating character.
Yep.
Because there's only 10. Hey there! Exclamation is 10.
Yep. In C, all C style string literals are going to be automatically null terminated. And I do want to point out that where this memory is allocated is actually really interesting. This memory, this hey there, is not actually allocated in, well, so actually, let me see. I actually kind of don't want to go over this right now because you'll notice that if I change this to implicit typing, we get a const character pointer. So I actually can't quite yet go over some of the things. And that's kind of why strings are a little bit of a pain to work with, because strings, as you see right here in this case, where we have a string of 10 characters long, it's a string of 10 characters long. No memory is being dynamically allocated, and as a result, you're not going to be able to decide how long a string should be to contain all the data that you want to store in it, which makes them not very useful when used as a static construct. But the thing about what's going on, or what would have to go on behind the scenes in order to facilitate creating a string of arbitrary length, is you would have to, by definition, allocate dynamic memory, which again goes hand in hand with pointers. Oh, implicit typing is not wrong in this case. I just don't want to do it here because it's going to try to stuff it into it's going to try to change the type into a pointer, which is not what we want to talk about. However, there is an implicit conversion between pointer and array types. So for most of the time, it's just better to do explicit counting. No, not really. This code right here has no difference between if I had done this, essentially. It's still allocating an array of 11 bytes. Well, 11 characters, and characters happen to be a single byte. If my string is 10 characters long, then I need one more slot for the null terminator. Yep. What is happening with cout bleh? Cout bleh, because this is an array of characters, and that array is 10 items long, we filled the first two indices with H and I, and then the third index with the null terminator. What cout is going to do is it's going to loop from the beginning of this array, so the first character that's pointing to, and then loop continuously over the array until it finds a null terminator, and then it's going to print out each one of these strings, or each one of these characters individually. Sure, a loop for, in this case would look something like this. We could say while true, well, let's just do this. Bool exit equals false. While not exit, we could say also we'll need an index. We could say char ch equals bleh at index plus plus, and then we can say if ch equals, or how about does not equal null terminator, then cout ch. Otherwise, set exit to true.
That's essentially what's going on under the hood at line 20 at the cout line, yes?
Yes, I did delete that line, but as you see, we get hi printed out to the screen. I do want to point out, however, that this code doesn't have any concept of bounds checking. So, for example, if I didn't have this null terminator, it's going to loop on continuously into memory until it finds something that's a null terminator. So that's something very important to be aware of, because there's no, with arrays, there's no concept of length. So cout is not informed of how long bleh is. The only indication of how long it is via the null terminator. So /n is the new line, yes. Are null terminated strings preferable way to work in a strings C++ as a backwards compatible with C? Are C-style strings more efficient than using C++ string class? We're going to be getting into the C++ string class, but I could point out really quickly that the standard C++ string class is just a wrapper around a C-style string.
You're going to get more into that later, aren't you?
Yeah. So hey there is okay because the compiler counts the number of characters and gives the array size of 11. Yeah, this is fine because the compiler will magically insert a null terminator. The compiler automatically inserts a null terminator on any constant string literal that you type into C++, including this, in fact. This gets a null terminator at the end of it because that's how the C++ compiler works. That's how the C++ specification works.
Yeah, /n is a new line.
Should bleh 3 through bleh 9 be initialized because bleh now has an expected value? I wouldn't initialize the rest of these values. And here's why. I know that slightly contradicts what I said before, but the behavior of C-style strings kind of does invalidate that that previous thing that I said about initializing arrays, simply because it has a language implicitly built into the concept of a character array that once you reach the null terminator, you are done processing the string. So you never should, as long as you have a null terminator in your string at some point, you shouldn't have to worry about uninitialized values if you're using an array of strings, because it doesn't matter.
Ties into the next question, which is what happens if there would be more characters in the array after the terminator?
They don't get displayed. So if I were to say bleh 3 equals h again, I'm just going to get high. And I can go ahead and delete this loop and use cout again. So it is possible to terminate a string in the middle of it, and then what happens after that is that the rest of the string does not get processed, because the null terminator is the indication that execution should stop. If you were to assign bleh as bleh equals to hey there, that means that the 11th character is going to be a terminator. Yes, the 11th character in this string literal is a terminator, just like the second character in this string is a terminator.
In order for the 10th character to be the terminator, you would lose the explanation point.
Right. And this isn't any sort of like special dynamic memory allocation. This is just the C++ compiler adding something to string literals.
So is there a more... Oh, another question.
So would you lose the last index in bleh because it's replaced with null terminator? Bleh does not get replaced with a null terminator. I'm manually assigning it. So I'm manually giving it data. However, because I've statically initialized it to a 10-element character array, the valid amount of characters that I can place into this character array is going to be 9 characters, not 10. Because the 10th character of this array is going to be reserved for the null terminator.
And we did just have a question that is the null terminator equal to a new line?
No. The null terminator is simply another escape sequence. An escape sequence is a sequence preceded by a slash and another character. And as you see right here, this is going to be the escape sequence for a null terminator. This is going to be the escape sequence for a new line. So if we did this inside of hey there, would we just get hey? And the answer is going to be yes, because we've essentially terminated, well, we get the space in there because the terminator ends after the space. We've terminated that string in the middle of it. What happens if you put in more than one character in a character? You can't put more than one character into a character. The character data
That's
I don't know. One of my VMs just decided to stop.
Apparently so.
Wonder which one. Okay, so a character data type. Oh, what? Great.
Is VS still working?
Now my entire VM is old. Oh, that's nice. It just took my video card away from my VM.
Huh. Okay.
Which I don't think is a problem with my host, because my host is still rendering things just fine.
Yeah, keep
Whatever.
using.
Okay. So a character data type will only allocate a single byte of information, and as a result, you can only store a single value into a character. And I mean, well, you can
You'll
only
get a
store
compiler error, won't you?
Actually, no, you won't.
Will you not?
You get a truncation of constant value, but you don't get a compiler error. In this case, we just get two I's, which is nice, I guess. Not really. I've seen a lot of people do like this and then wonder why their characters don't get printed out. The character literal syntax in C++ does not enforce that it's one character in length.
And we did another question here. Is \0 the same as null?
I thought I already answered that.
No, you answered a similar question.
Yeah,
people don't seem to be associating what you're calling, what you're saying, with that particular symbol. \0 is the null terminator that he keeps referring to.
Right. And it is basically just going to turn into 0. But I still prefer this because it's a little bit more explicit. I do not recommend you do this. And the reason is like I've already said, C++ is very liberal about the type system. That being said, conceptually, a value of null has a very special and specific meaning inside the C++ language. And just taking advantage of the fact that it happens to be the integer 0 is irrelevant, because although I can do null plus 1 just fine, because null is just a constant for 0, this conceptually makes no sense, because null has its own specific meaning within the language, and doing any sort of arithmetic or conversion between null and any other data type, I highly discourage from a readability standpoint. Because, like I said, conceptually, it's just not appropriate in this particular expression. Just like true plus 5, this makes no sense, but it works. Using null in place of 0 is like using true in place of 1. And I don't like seeing that, because it doesn't follow with what you're using types to express. Types should be their own thing. So although you can do this or this, I still vastly prefer this, because this actually says something about what you're attempting to do. It gives the reader of your code more of a context that you are indeed terminating a string.
And Gavin, real quick, when you get a second, check the chat in your webinar.
Mm-hmm. The chat in the webinar.
Yes.
I don't know how to do that.
You've sent me chat messages quite a few times there in the past.
No, I have now read your message. I'm saying I don't know how to do that.
You should be able to simply click on answerer.
Okay, as a test.
Just, anything that allows it to be indicated that it has been answered. We're just trying to come up with a way to keep...
yeah, because when I delete them from my list, they don't get deleted from yours.
Correct.
Which is weird. Oh, I could do that.
Yeah, that's fine.
Okay.
So anything over there, Nelson,
yeah,
with
no problem.
with a red mark is has already been answered.
Okay. Somebody asked if this was valid code, and the answer is no, because this is a statically allocated array. There's no way to statically allocate an array without knowing its size. And this, by assigning it to an initializer that's valid for a character, or that's valid for an array, allows you to not have to specify the size because this is known at compile time. Just like if I had done this. This syntax, because the syntax actually spells out to the compiler how long the string should be, you'll notice if I hover over it, it says character mystring 3. We are leading up to the string class, but I want to make sure that people understand the basic concepts of what a string is in C++ before we get there. Or what a null terminated string is. So are there any more questions about null terminated strings?
I may have missed it. Did you answer the question at 39 minutes past?
Yes. This is not valid code because this is a statically initialized array, and you cannot statically initialize anything without knowing the size at compile time. Null terminator only terminates strings? Yes. The concept of a null terminator string is something that's basically, it's just a concept that's encoded, or a standard, or a convention that's encoded into the language and the frameworks and libraries within the language.
It's literally like planting a sign there that says stop.
Right, and then other libraries understand that language, and as a result, they know when to terminate. Can you discuss any issues with cin and C style strings? Well, you're going to be running into issues with cin and C style strings. And to be honest, I've never tried to compile this particular thing before, because there is a function we can use in cin instead of this. And of course, this does compile. I should have expected it to compile. And as you see, because I've inserted more than 10 characters, we get a runtime check failure 2 stacked around the variable ble was corrupt, which means that we had a nice little buffer overrun. What you would want to do instead is say cin.get, and then you would want to pass in a something like the string itself, followed by the count of how many items that string is. So by specifying cin.get, what we get here is, well, hold on, the proper behavior. And if we overflow, we get just an undefined condition that leads into input validation, which we haven't quite gone over yet. We'll talk about input validation at some point. So this is the safe way to use cin with a character array.
So are any more questions about what Nelson said up to this point?
Cin.ignore, again, is just a way to eat some stuff that's in the buffer. For example, if I were to specify that I wanted to grab an integer from the user, the new line character that I would have to hit would get eaten, or would get placed into the cin buffer. And then when I specified cin.get, the result is it's going to return the new line that was was not eaten, and we're going to get an immediate return. And if we get an immediate return, the console window is not going to stay open.
Okay, I will do a deal with everyone now. Can we all agree that that question has now been answered about cin.ignore? Please. Because it's been answered in every class so far and in the open hours. It's definitely on video somewhere.
Okay, so I guess now we can quickly introduce the concept of the std string class. So the std string class is available to us through the string header. And what it is it's essentially a standardized wrapper around a C-style string. And it gives us some nice built-in functionality and some level of safety and a built-in sort of a built-in way to interact with some of the other standard libraries, such as cin and cout. So a string class, let's go ahead and look at this. So we haven't really talked about classes and objects yet, but you're going to have a quick run through of what a class and object is, at least at this point, to understand what this is doing. And if you'll notice, it does look a whole lot like a normal variable, where if we have an int my number, we have a variable. The variable has a type of int, and it has an identifier, my number, which identifies the location in memory that we can use to access that data. You'll notice that this looks very similar. We have a string, and then that's followed by an identifier ble. However, string is not built into the language itself. Now, of course, it's in the standard library, so it's going to be available to us on every single standard compliant C++ compiler we use, but it's not a primitive data type. It's not like integer. Now, remember how our primitive data types, integer, Boolean, floats, doubles, characters, unsigned, signed, blah, blah, blah. Those are just ways to ask for memory from the C++ compilers, so that the C++ compiler generates the proper machine language to ask for a specified amount of memory. And then the C++ compiler also attributes some other behaviors onto the data or onto the variable depending on its type. Now, a string is a type. It's a data type. It's not a primitive. It's a class, and it's a class that's available to us by the, again, by the standard C++ library. What we've done here is we've not necessarily instructed the C++ compiler to allocate a specific amount of memory for us. What we've in effect done is reuse some functionality that was defined in this string header that's going to perform a lot of operations for us. It's kind of a wrapper around a C-style string. And it's going to manage the memory that we need in order to work with C-style strings so that we can store arbitrary length strings inside of our program. So what we have here, ble is actually called, it's called an object. And you'll notice that it is kind of weird if you are coming from other languages where we don't actually instantiate this object. And the reason we don't really instantiate it, I guess you could say we do in a roundabout way, but the reason we don't is because this memory is being allocated for us entirely on the stack. The memory required to contain the string variable is available to us on the stack when int main is invoked. This, again, is not dynamic memory allocation. Now, I do want to point out that string itself is going to allocate memory dynamically for us, but it's going to manage that memory. So we don't necessarily need to worry about it as long as we don't dynamically instantiate a string, which will in turn dynamically instantiate memory behind the scenes for us. So we have what's called an object. Ble is an object. And one of the properties of an object is that it has some very high-level behavior associated with it. Now, int my number does not have behavior in itself. the way that the C++ compiler treats an integer is defined in the standard, and it's not going to be anything that really advanced. The C++ standard defines some conversions with integer numbers, defines how method or function overloading works in regards to integers and other data or primitive data types. But what we have here is a big bag of functionality that we've essentially made available to our int main function at this point in the form of an object. And one of the things about objects is that we can access members inside of it using the dot syntax. So you'll notice by saying blah dot, I get this nice little pop-up that includes a bunch of these things. These are all bits of functionality that we can use on this object in order to perform some sort of operation. So let's go ahead and see what we can do with strings. So what we've in effect done is we have declared a string, and we've assigned it, check this out, we've assigned it to a string literal. What's going on here behind the scenes is actually really important, because unlike assigning int my number to the value of 10, which will literally result in the value 10 being stuffed into this memory, instead what happens here is that this character or this string literal is being passed into some special behavior on this object itself, which performs its own operations as far as actually getting this memory inside of this object. When we do cout blah, this isn't anything magical either. Cout, again, like I said before, the standard C++ library has a concept of strings. All the input and output functionality in the standard C++ library knows about strings. So by outputting a string, we're not invoking some sort of magical C++ feature. Instead, we are just accessing the behavior inside of cout that understands what a C++ string object is. Okay, are there any questions about strings so far?
There's one there just come in from Dane. So the assignment operator is overloaded for the string class?
Yes.
And Buzz, if you could just look at the chat.
Do what now?
In our chat. If you could just, did you see that? Do you now see a tick next to that test question I got Steve to ask?
Yes.
Cool.
Yeah,
Okay.
much better. And thank you, Kevin. Nelson, that'll help you identify what's not been answered quickly if it doesn't have a check by it.
Alrighty. Short question. Why use character when we have string? The answer to that question is going to be up to you, depending on what sort of thing that you are doing. When we get into dynamic memory allocation and pointers, there are going to be some scenarios where it would seem more appropriate to use to use character pointers rather than the string class. However, the string class is going to provide a bunch of functionality for us. However, it is not perfect. For example, we get some very bizarre behavior with that. So it's not going to behave as you expect during certain circumstances. As you see by by adding my number to it, we get LD explanation point, which does actually have a sort of defined behavior in this case, but it isn't a trivial thing to explain. I mean, there is a reason why that is indeed happening. So in that case, you would generally want to, so you're going to have a lot of fun with some of the built-in behaviors of the string class that don't quite mimic those of other string classes from other languages, which might cause some level of frustration. Which is kind of why, so as you see here, what we've done is we've attempted to append on a number, but instead we get some garbage at the end of the string. So quite a few different, and SegFault, you are correct, that's what's happening, which is funny. But yeah. So the string class creates dynamic memory through the overloaded equals. It doesn't necessarily have to. I believe that it will in this case. Because this is a constant, the string could technically assign itself to, or assign its internal pointer to this constant character pointer, but it doesn't necessarily have to. And the thing about classes and the way classes work is the implementation is entirely up to, well, the implementers. So we don't have to do string stuff equals new string because the class handles it for us, or is this a C++ feature? The reason we don't have to use the new operator with objects in C++ is that it's possible to allocate objects on the stack as opposed to only being able to allocate objects on the heap. There is a new operator in C++, which we will be going over very extensively, but it's not for use for instantiating objects necessarily. Now, it is going to be used for instantiating objects, but it's going to be used for allocating dynamic memory.
But
so it becomes a little bit more convoluted.
Unless I'm just having a minor meltdown, lines 8, 9, and 8 and 10 could be used exactly the same in C#. You don't have to because you're declaring it.
Yes, but it is a little bit what happens behind the scenes is a little bit different with C#. C# strings are immutable. What happens here in C# is that you declare a null reference to a string, and then what happens here is the reference to the string is then assigned to a reference to a string literal. So it would look the exact same in C#, but what happens behind the scenes is different. This actually does instantiate an object in C++. It actually does allocate the required memory on the stack, of course, but it does allocate the required memory, and it does invoke the constructor of this object. It just doesn't, it's not a null reference like it would be in C#. This is not a reference. This is just a plain old object variable.
Cool. Someone did query, and you might slip past because it's only the one word. Someone was querying when you said about overloading operators, what the word overload means there.
Well, it has to do with, again, complex types. And that is something that I do just want to point out at some point early on, because we are going to get into making our own types. But you kind of, with C++, because it requires you to use some features like the string class or the vector class or whatever to get some functionality that you would have otherwise in different languages, you have to understand the difference between a primitive type and a more complex type. And a primitive type is just a compiler time thing. It's defined, the behavior of a primitive type in C++ is defined entirely by the compiler, and the type really only exists during compilation. It just gives the compiler a hint as to how to treat this data during compilation and what instructions to generate for the CPU. A more complicated type is a type that's built by somebody else and is not part of the C++ language itself and actually has behaviors that are described within the C++ language. By saying ble equals hello world, what we're doing is we're handing off this string literal hello world to an operator overload, which is a special thing inside of this object that is invoked when we assign it to a character literal. Or a string literal, sorry. So what happens there is C++ code actually gets executed right here. We can't see that code. Well, we could if we opened up the string header, but we can't see that code by default. When I do this, this actually just gets translated into a CPU instruction. There's nothing more complicated about it. Why does the string work in some IDE without include string? I don't know. Somebody asked if that's behavior of C++, Visual C++ 11. Remind me of that, and we'll take a look at it once we get over to that IDE later on, or Visual Studio 2012. Sorry. Is the main plus of stop character overflowing on user input? Yeah, the string class does hide the memory allocation from us entirely, and it does a decent job of making sure that we can't do anything stupid with it. As a result, if I were to do this, string blah, C in blah, then C out blah, you see that I do get the proper amount of memory allocated to store the string that I typed in. So that's good. Can you safely reassign a value to a string? Yes. So I could say string blah, blah equals hey, C out, and then blah equals whoa. And then if I were to run this, we would get the proper result. And the memory being allocated by the string class is going to be properly handled and deallocated when it needs to be. You guys can follow along with Visual Studio 2012, and one of the features that we're going to be going over is going to be only available in Visual Studio 2012, as well as GCC with a special compiler switch passed in.
There's a good one. If string is a data type, how come it's not in blue, same as int?
It's a type, but not a primitive type. It's not a type that's built into the C++ language itself. Although it is defined within the standard of C++, it's not built into the language. It's not a keyword. String is just a type. So for example, the reasons, if I were to take out this using namespace std, notice how string gets squigglied. That's because string is a member of the std namespace. It is a class inside of the std namespace, whereas int is a keyword that's accessible everywhere.
And in actual fact, the only reason it's blue in C# is because it's a keyword. The actual string with a capital, if you took a string that's blue and capitalize it, you'll see it turns cyan.
Right.
Does that mean cyan?
I think it's more of a teal.
Aquamarine. Yeah, teal, that's the word I was looking for.
Because that's a type. Yeah. Whereas string lowercase in C# is a keyword. However, string lowercase or uppercase in C++ is not a keyword.
And apparently in 2012 it's green.
Yeah, I think 2012 highlights types.
I did just spot someone in BuzzNet. All of these intricate colors, lol. Yeah, but they really, really help when you get used to what they mean. Yeah. You don't have to even read, you can just look at it and see the shape of your code. SM Jones, it's how you spell color properly. That's it. That's why I don't look at BuzzNet, you see.
Okay, is everybody more or less comfortable with the string class as of right now? Because we do have a few more things to talk about strings here, but I think that because we've already introduced C-style strings and C++ string classes, there might be some questions that people could answer while I'm outside.
Actually, I mean, we're really close to the 1 hour mark, so if you're about to switch gears on a different topic, then we can go ahead and go on our 10-minute break. And for those of you that have questions, this is a perfect opportunity to compose them and put them over in the webinar questions panel. So feel free to do that. We'll go ahead and take a 10-minute break now, and we will get back to it right afterwards. I'll go ahead and pause the video as well. All right, Nelson, we've now resumed the recording of this class. Let's take a look over in the questions panel and see what kind of questions have come in.
Okay, so what can you do with the dot operator with strings? There is one thing that we are going to be talking, or two things that we're going to be talking about that we can do with the dot operator. At the end of a string in this class, we're going to be talking about size and length, but and we can talk about a few others, I suppose. There are some interesting behaviors that we have with strings. We have append, which allows us to append, well, a string to it, basic concatenation, which is basically just an alias for the plus equals operator. We do have the other ones such as clear for clearing everything in the string. We have things like cster and, wow, cster. That sounds like a villain saying sister or something. C string, which gives us access to the underlying C string that's being wrapped by our string. And then we will be talking about the size and length members in a moment here once we get past.
Would now, you've gone away. I was going to say, would now be a good point to just talk about what all that blah is that you get from, if you go back into dot to dot and.
Well, what you mean, the members?
Yeah.
Just in general?
Because they're rather harder to read than they are in other languages.
Yeah, these are just members of this object. Remember how I said that this is a type? Specifically, it's a class inside of C++ that provides us functionality for any object that we create with this type. And we use the dot operator to access that functionality. Well, we have right here what are called methods. And you know that they're methods because of the nice little purple box thing with the little lines. I don't know what the idiom here is.
We know they're methods because of this icon right here.
Yes. And methods are basically functions that we can execute in the context of a particular object, meaning they're special functions that we can invoke that are attached to the data that this specific object contains. We also see that we have some fields like npos, which is not important right now. We have some operators. We have the append operator, the assignment operator, and then the bracket operator for accessing specific characters. And then we have some constants, and that's about it, really. So yeah, that's just the general concept of what they are. Okay, so I used some code, the last result size of my string, outputting the result for small, medium, and large strings. It always returned 32 bytes. So is my string just a pointer to memory? Okay, that's actually a good question, which actually leads into the length and size. So I'll answer the other questions first, which it doesn't seem like there are any more. Okay, so moving on from basic string usage, now that we've gone through basically an overview of strings and how we can use them inside of C++, or at least some basic usage of strings, let's go ahead and talk about some of the members of the string class. So somebody asked a question, I suppose what they're looking for is how to get the length of a string. Now you'll notice that if I do character stir array equals hey there, and I perform a size of operation on this, we're going to get the proper output. We're going to get 11, so that's great. However, if I say string bleh equals hey there, and I do cout size of bleh, let's look at what we get. We get 32, which is kind of weird. If we do this, if we, let's say, assign another string character to blah and do another size of, what do we get? We get 32 again. what's going on here is the string class, again, only wraps around it enough memory to hold a pointer to the dynamic memory that's going to contain the string data itself. So the string class itself cannot be used with the size of operator to get the result that we want, because the size of operator only returns how much memory is allocated on the stack in order to support the existence of that object. We did not go over pointers, but I won't refrain from using the word pointer, so we'll have some things to talk about once we get to pointers. So the size of operator is just going to return the amount of data that it requires for a string to be on the stack. It does not return the amount of dynamic memory that's been allocated to hold the data that we're storing within the string. Now, to get that data, we have two options. We have the size method, and we have the length method. Now, here's the thing. So we get size 10, length 10. So let's go ahead and do the other example again, where we'll reinitialize this string to a lot of more stuff and print it again. And now you'll notice that we get 11, which is the size of that string, which is the proper result. Then the size method on the string ble, when it contains hey there, is 10. The length is also 10. Same here. The size of the string is 42, and the length is 42. I do want to point out really quickly, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that there are 10 characters in this. The size and the length method refer to how many actual characters are in the string, not including the null terminator. I want to point out that these two methods do the exact same thing, if you haven't already noticed. The reason for their existence is that the C++ standard, when they designed the string class, they wanted to treat the string class like other collections in the C++ language. So to make it compatible with the other collections, or to make it similar looking to the other types of collections, they included the size method. Then they also included the length method because, well, saying .length is a little bit more intuitive than saying .size when referring to strings. So they do the same thing. So any questions about size and length?
And if you think about it, it would be incredibly confusing if it did count the null terminator. It would be mind-bending when you start doing looping things with it, because you'd always have to remember an extra minus or +1 here or there to make things work. It'd be horrible.
Right. And as a result, yeah, it doesn't include it because the /n is really just abstraction that the string class abstracts away from us, or the /0, the null terminator. So Segfault asks if this implements some of the interfaces within the standard library, and if that doesn't make sense, that's fine. The answer is going to be, I am fairly certain, no. And when we get into templates, it'll make more sense when we start talking about the size method. Because once we get into templates, which is not going to be covered in this course, but once we do, the existence of the size method actually has a reasoning to it. Okay, any more questions about size and length?
Could rephrase that.
Any more questions about size and length? Can I? Okay, so moving on. I guess the last thing to talk about really quickly is concatenation. Yeah, concatenation, really straightforward. What we have here is basically appending a string onto itself. Concatenation supports both appending string literals as well as other string objects. So I could say string hello equals hello, string world equals world, and string hello world equals hello plus world. So it behaves like you would expect. I do want to point out that concatenation does not work with other data types. Unlike other languages, you cannot concatenate an integer or a Boolean or a floating point number into a string. Now, there is a way to do this. There's something called the string stream, which does allow you to do concatenation with other types, and it behaves a lot like cout, but that's going to get into a little bit more complicated stuff. However, I guess because I like you guys so much, it might be interesting to go over the string stream just because it does allow you to do stuff. When you think about concatenation, you typically think about being able to concatenate on a variety of different data types. And the C++ string class does not natively support that. So what if
you? Yeah, I was just going to say. So what if you were getting the username, the user's name? I mean, the user's age. Sorry.
What if you're getting the user's name?
Age. Because you're wanting to demonstrate ints.
Yeah, if we wanted to get the age and print it out or append it onto a string. So we have. Oh, somebody does ask actually a good question. Why doesn't this work? Which is a very good question. And the reasoning is that the C++ specification does not have any concept of string behavior outside that of basic C-style null terminated strings being turned into character pointers or arrays depending on context. Meaning that these string literals are not objects, unlike other languages. As a result, there is no addition operator specified for character pointer plus character pointer.
Is that where they've overloaded it onto the bitwise shift?
No, there's no bitwise shift on the string class.
The left pointing arrows?
No, not on the string class.
Huh.
So this doesn't work just because, yeah, it just doesn't work. There's no way to add these two things together. See, in C# or Java or other languages, this syntax, a string literal, turns into an object. In C++, it does not turn into an object. It turns into, like I said, either a constant string pointer or a string array, depending on context. So what we get here is we get two things trying to be added together that the C++ compiler does not know about.
You mean character array? Yes? Not
What
string array. You said this string turns into a string array.
Character array. So how would we do this? Well, we could do this. See, this doesn't work, but this does. The reasoning this does is this is a fundamentally different operation. This is telling the C++ compiler to add two character pointers to each other. This is telling C++, okay, go ahead and use the equals operator that's overloaded on the string class to pass in a character pointer into the string object. Then it's saying, use the plus equals operator overload to add the world character literal or string literal into the hello world object. So this is how you would concatenate two string literals into a string class.
So how do you go about adding a number then?
Okay, so yeah, and that's going to be with the string stream. And this is one of the things that I wished somebody actually taught me when I was learning C++ for the first time. And that is going to be made available to us in the sstream header. And this will allow us to declare another object that's inside this std namespace, and that object is going to be called the string stream. So let's call this SS. So the string stream behaves like cout, but it allows us to get back a string class if we wanted to. So let's talk about how we would get an age concatenated onto a string. Let's say we have string name, cout, name, cin, name, and then int age, which I'm just going to go ahead and declare up here just because. Cout age, cin age. So let's say we wanted to concatenate the name with the age. Well, we can do this with the string stream. We can use it just like cout. We can say string stream, let's concatenate on name, and then is age years old. So that allows us to use it just like cout. And now that we've done this operation, we can now say string output equals ss dot what's that method called? Str. STR.
Will cout take a string stream directly?
I don't know. Nope.
No.
So what we do is we get the string object outside of the string stream and we print it out to cout.
But, so presumably, if you specified age as a string right at the top,
yes, if age
would
was
that work, or would you end up with oddities?
Nope.
Odd oddities.
Yes, very strange oddities. You wouldn't. It would work just fine because the string only can be concatenated with other strings. And if age were a string, then it would work just fine. So string stream is more commonly used because it makes no sense. No, string stream is used to get some behavior out of the string class that isn't built into it by default. A behavior that people would really intuitively expect it to contain, but it doesn't. So I wanted to just introduce this while we're talking about concatenation, because being able to concatenate multiple data types into a string is a very common use case.
So is string stream the place to go and look for the things that you would expect to find on a string in C#?
As far as conversion goes, yes.
There were a couple of questions that came in a little bit earlier, just short ones.
Is string stream a wrapper? Not that I know of. It's just a class that understands the same syntax as cin or as cout. String stream. Well, yeah, string stream doesn't. Actually, I don't know if it wraps a string. I don't know what internal representation it uses right here. All I know is that when you invoke the str method on it, you get back a string object.
How to chain multiple concatenations, and the one above that.
Where?
27 minutes past.
Oh, I already did answer that. That you can't. With string literals.
Which one? The second one?
Yeah, how to chain multiple concatenation. Does string class allow for an array of strings the way primitives do? Yes. The array type can be applied to anything. So for example, I could say string product names 4, and I could say int index equals 0 while index is smaller than 4. Cin product names at index. And then I can say index equals 0, well, derp. while index smaller than 4, C out product names, index new line, index plus plus.
And someone put, sorry, I'm not sure what string gives you that string doesn't.
String is the data type that you use to hold string values inside of. String is a way to concatenate multiple data types into a string. So I can say string 42, hey there, for example. And then I could say string output equals ss.stir. What this is doing is this is saying, okay, give me the functionality of concatenating multiple data types into a single string. Then finally give me the output. String doesn't carry data around with it. You can't access the data within string in a way that is that makes sense necessarily.
So how did that ss.str work then?
That's the way to access the data. String is the data. The string type is the data of a string. String stream is a way to create a string out of multiple various data types. String stream is like a buffer with functionality. Yeah, it works just like cout, except for instead of printing into the console window, it prints into its own internal representation that you can use to turn around and get a string out of. Basically, lets you write a sentence in one variable. Yeah, it allows you to construct a string from multiple data types. Is stir a global object method like toString in C#? Nope, it is not. In C++, there is no base class, and as a result, there are no functions that are available on all types. Types declare their own functionality and are not related to a base type. What do I mean by multiple data types? I mean that we are concatenating an integer and a string literal into a string object. See, otherwise,
Int, string, char, float, double, they're all different data types.
although this compiles, this does not work as expected. Can you kind of guess why that this isn't working as expected? The 42 integer is not being converted. The string does not know anything about integers or floats or doubles or precision or formatting or currency or cultures or anything. It is a very stupid object. And by stupid, I don't mean not useful. I mean just not very intelligent. It doesn't have function.
Sorry.
Yeah,
it's doing exactly what you tell it to, because 42 is, as somebody I think just pointed out, WedgeBob pointed out, that's the ASCII for an asterisk.
Yep. Since somebody asked, can you cast an integer to a string? Yeah, have fun with that. I could say string 42 if I wanted to, or does it not? I could have sworn it had a constructor that took a, never mind, it doesn't have a constructor that takes an integer. So you can't do this with strings, with the string type. But if you really wanted to, you could do this. But guess what happens?
Where do you get the asterisk again?
We get a nice little access violation.
Ooh.
And a bunch of assembly. The reason we get an access violation is this, remember, this type right here, const character pointer, although we're not talking necessarily about pointers just yet, this is the type for these string literals. And I can prove that by doing this. If you hover over this variable, you'll notice that the implicit typing gave it a const character pointer. But what's happening here is by casting 42 to a const character pointer, we're not actually performing a conversion. We're telling the C++ compiler to treat the variable 42 as if it were a valid pointer into memory. And then when it tries to go and copy that data, we get an access violation because presumably 42, the memory address of 42, is going to be
something to do with Windows. Or
yeah, it's probably like some sort of
Windows.exe. Would using string stream all the time be a bad idea?
Yes. You only want to use string stream when you have a reason to use it. And string stream is only going to be used to convert different types to strings for processing. You can also, okay, I do want to point out just one more interesting thing you can do with string stream before I move on. Again, I don't consider this out of scope because this is vital for concatenation. But there is one cool little thing we can do with it that's slightly out of scope. That's lots of fun. So let's say we wanted to convert the string literal 42 into an integer. We can do so with string streams. We can convert numbers into numeric data types. So for example, I could say 42.4, change this into a double, and we'll get the proper result. So this is a way to do some back and forth converting between strings and built-in types.
Out of interest, if where it now says 42.4, you put an asterisk in.
Like right there?
Instead of 42.4.
It tries its best.
It fails. I just wondered if it worked that way around as well. Never mind.
New segfault does point out something nasty again. Most people here aren't going to understand the syntax, but it leads back to the thing we had earlier about can you in any way cast a number into a string? And there are a variety of syntax that look like they could be correct, but they simply will not be. I just want to drill this point home, that there is no way to cast a string into or a number into a string. See, I get an access violation again.
Although, interestingly, it did show up. Did it show up the hex for 42 that time, wasn't it?
Before I used
the sum's wrong.
Before I used the dereferencing operator.
Ah.
But we'll get into that once we start talking about pointers. But this is dangerous. If you had a character, it would be in there. It'd be messy.
The int passing from the string, like you did with the 42.4. That was referring to. Do it with a slightly less silly example. I want to see if I can.
It's just going to do its best. And in this case, it did a pretty good job of finding the first instance of a character that wasn't possible to be converted. Now, if we start with garbage, it's again going to try to do its best, but it's most likely going to fail miserably.
I think we could probably get sucked into a vortex of complexity here.
Well, welcome to C++.
Yeah. I was just thinking, yeah, dragging, because I'm interested by what exactly is going on here, but I think this is going a bit beyond 101.
Yeah, just wanted to point out, though, that people coming from other languages might be frustrated that there's no simple analog to some other things. And this is, I just wanted to introduce this so that people were made aware of how to perform these operations. Okay, any more questions about strings, concatenation, initialization, declaration, size, or length? Because everything else is going to be very simple from here on out.
Oh, that's interesting. Space has a character input.
That gets into a very interesting
Do you just want to show that
behavior.
example?
Yeah, I don't want to get too far into this because there are ways to do what he wants to do, but they are going to start involving the concept of pointers to do properly. But I will pull in this example just to make people aware of this.
Yeah, because it looks like if he's trying to store a name variable rather than a first name and a last name, people might well try and do that.
Right. So if you go ahead and hit F5 and you type in, Nelson Lackey, and, well, actually what's happening there, you're not seeing it. Let me go ahead and get a control.
I saw it just. Yeah.
See, Nelson gets sent into the, actually, hold on. What's going on? Oh yeah, Nelson gets sent into the buffer, and then the cin will only work until it finds a space. Then it will stop eating characters for input into a string, so it will only grab the first name out of the buffer. Then age gets Lackey, which turns into this, and then everything else just freaks out.
So if you added a line 13, the same as line 12, but with the equivalent of name plus equals cin at 13.
Name plus equals cin? You mean that?
No, well, at line 13, not line 12. Copy line 12, put it in again, and change the one on 12 to first name and the one on, to last name.
Oh, yeah. In this case, you would do first and then last if you wanted that behavior.
That would actually work, would it?
Yeah. But I don't want to get too far into this either. And the reason is in order to do this properly will require the a method. Well, I guess I can just show it. Whatever. There's a method on cin, because I've already been showing methods on cin. There's a method on cin called getLine. And getLine will allow us to pass in a string and pass in a count of how many characters we want to support for this line. And this will work as expected. Or not. For some reason, the string overload or the string overload to cin.getLine doesn't seem to be behaving. Huh. See, this is what I wanted to avoid, because in order to use getLine, at least these overloads, okay, I forgot the overloads. It expects a character pointer, which gets into, well, character pointers. So
well, just wrapping that up, though, Chris's last question, because that's kind of what I was aiming for, but I forgot the syntax.
He asks if we do cin name. We just get the last.
No, that's not quite what he put. He did the two cin name. lines?
It's going to be the same behavior, regardless. That's going to be perfectly equivalent.
That's what I was aiming at when I was saying plus equals. I mean, is there any way to concatenate?
No, not that I know of. Actually, I might have lied. I think I was looking for this method, or this function. Let's try one more thing. If this doesn't work, it's not my fault. I confused myself. Okay, there we go.
There's sufficiently wrong values of not.
Where I was getting confused is I forgot that this is actually a global function. Although there is another cin.getLine method that does accept a character pointer, I forgot that that's actually not the one I wanted. What I wanted was just the function getLine. And by saying getLine, giving it an input object, cin, and then giving it name, which is a string, we get the correct behavior.
And someone said, doesn't cin.gets read white space?
Doesn't cin.getS. I've always used getLine actually, but let's try gets. There's no gets. Not on my compiler anyway. So what's a global function? A global function is just a function that's not associated. It's just a function. Main is a global function. A non-global
We'll get into
function,
that when you get into, well, functions.
right. These are not global functions. Cin.ignore and cin.get aren't, because you need to invoke them in terms of a cin object. GetLine is a global function because we don't need to invoke it in terms of any other. Okay, so moving on. Any more questions about strings, string streams, or concatenation or anything like that? Because again, everything else is going to be pretty much, we're going to breeze through. Alrighty. Let's talk really quickly about basic debugging. We have already demonstrated some basic debugging. So I will not need to talk about this too much. Okay, so what's a debugger? A debugger is a program that attaches onto another process and allows us to control the execution of that other process. It allows us to introspect memory that that process is using and step through how that process executes the code that it has on it. So let's go ahead and show a simple example. The basic way that we get to using the debugger in many of the IDEs, all of them if I'm not mistaken, is going to be with the concept of a breakpoint. And a breakpoint is a point in your code where execution will halt and the debugger will take control and actually pause the execution and allow you to introspect the process. So by setting a breakpoint here on line 8, I can go ahead and hit F5, and you'll notice that the console window did open, but nothing's printed out to it. And in addition, you'll notice Visual Studio changed up a little bit. It looks a little different. And we're sitting here with a pointer pointing to, well, not a C++ pointer, a literal arrow, pointing to line 8, indicating that we have paused execution immediately before this line was to run. So what can we do in the debugger? Well, we can introspect variables by hovering over them. As you see, index equals this null garbage values. You can pin these values by hitting that button. You can watch them in your watch window by typing in an expression, such as index, and we get a value. We can look at them in our locals window, and they'll automatically appear. And we can look at the autos window, too, which will automatically appear.
You just want to point out exactly where to get at all your debugging windows if they're not visible.
Yes, if any of these windows are not visible, you can get to them by going to, and this is important, to get to these windows, you must be in debug mode. These menu options will not appear if you're not in debug mode. But if you are in debug mode, go up to the debug menu item, go down to Windows, and you'll be able to open up all your debug windows. So there are a few buttons that are very important with debugging. I can hit Shift F5 to end debugging. I can hit F5 to continue execution of the program. And when I do hit F5, it's important to notice that it's going to continue execution until the end of the program or until the next breakpoint. So if I hit F5 from here, you'll notice the execution jumped from line 8 to line 15. And if I go to my console window, you'll see 0 through 9 being printed out. In addition, you'll notice that this and this in my watch turned red. We'll talk about that once we go over the step over button. Step over button in Visual Studio is going.
I was just on that last point. If you put a breakpoint on line 11, it will break every time. Even if you hit F5, it will break every time it hits it.
Yes. So I can continuously hit F5, 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 F5 until the loop terminates. So it's not just going to pass over at once. It's going to continuously break whenever execution reaches this line through whatever means that happens. Okay, so F10, which is the step over button, will, well, step forward. So you'll notice that we were sitting here on line 8, and now we're on line 9. The pointer points to the next thing, the arrow points to the next line that's going to be executed. So when I was sitting on line 8 had not executed yet. But when I hit F10, it did execute, and the arrow moved down to line 9. You'll notice that index right here turned red. So did this value down here. This indicates that the value of what we're watching has changed between us executing more parts of the program. So now if I go ahead and hit F10 again, you'll notice that this turns back to black because it has not changed. And if I hit F10 again, we'll just continuously loop through this loop. But if I look over my console window, you'll notice that the line 11 did indeed execute. So now I can continuously loop and loop and loop and blah, blah, blah. And
is that F10?
Yes. In C++, be very wary of the step into. Now, we're not going to be really talking about step into or step out of or the call stack window, because these features will become a lot more important once we talk about functions next week. However, be very, very careful with the step into button when hovering over lines like this, because if I were to hit F11, now we're looking at some of the most terrifying code that's ever been written. And the fact that they think these comments help at all is just hilarious. Okay.
So that clearly works differently than the way it does in the C# Visual Studio. That's why I was surprised that you were I thought you'd actually were pressing the wrong button on your keyboard.
Yeah, it does work. It does work differently in C#, because C# by default will not step into code it doesn't have source code for, and it won't step into code that you didn't write by default. And in addition, something about the standard C++ library is because they use templates, it means that all the source code is available to you by definition. So you can step through cout if you wanted to. If you ever wondered what happened when you step through cout, here it is.
We did have a question come in. What if nothing happens when pressing F10?
Nothing can't happen when you press F10. I guess you could be talking about cin.get. Because if I hit F10 right here and this happens, that means the execution of the program is resumed again, because we're sitting here waiting inside of the cin.get method, meaning we have to jump all the way back to the console and provide some input for execution to resume again in the debugger. If you ever wonder what happens in cout, you can step through it and wonder what happens in cout.
Excellent.
Okay, any questions about the debugger? because yeah, you can figure it out. It's commented. I mean, you can read that code. Like, it is possible to read the code, but I just always loved, like, when I was learning C++ and I would jump in. I was like, oh, I wonder how cout works, and then
ran screaming from the room when he saw it.
yeah.
What's the next subject on the list?
We're going to be jumping into for loops now, if there are no questions about debugging, which
I wondered
doesn't
if
look like there is.
We've just gone past the hour, probably about 10 minutes short of where we
Nope, we got about
take a break.
we got about 20 more minutes until break
All right,
time,
cool. Excellent.
which is perfect
Not quite yet, Steve.
for covering for loops.
Okay, so let's talk about for loops. What is a for loop? A for loop is a loop construct in many languages that hopefully anybody who's coming from another language should be familiar with. And if you're not coming from another language, they are pretty straightforward. Just like while loops, where a while loop has three parts. It has the while keyword, the expression that goes in the parentheses right here to determine when the while loop should terminate, and then a block of code that will be repeatedly executed. Now, the for loop looks very similar. The for loop has the for keyword, followed by parentheses, which some important stuff goes in here, followed by a block of code that's going to be repeatedly executed. Now, what goes into a for loop is the declaration, followed by a semi, followed by the condition, followed by a semi, followed by the action, followed by nothing. So a for loop, this is the structure of a for loop. We have three parts inside of these parentheses. We have the variable declaration, the condition, and the action. And for some reason, I can't click on this line of code. Oh, there we go. I still, what? I don't even know. Okay, so let's go ahead and talk about what this is. We have a variable declaration, a condition, and an action. Basically, this is perfectly equivalent to if I had done this.
And this is why he kept forgetting the index plus plus in the while loops.
Yeah, I'm not really generally used to seeing them. Okay, so what we have here is two similar looping constructs, or at least two looping constructs that do the same thing. It's just the for loop is a lot more compact. Because of the for loop, people identified that this is such a very common scenario that they encoded it into the language itself. So yeah, we have the initialization, which initializes the variable I to 0, the new variable I to 0, which is nice. We have the condition, which is going to be, as long as this remains true, the loop will continue to execute. And then we have the action. We have a bit of code that's going to be run after every iteration of the for loop. Okay, so, well, any questions? I guess I can go ahead and fire up the debugger and show you guys.
So you could actually go float I equals 0, I is less than 1, I plus equals 0.1 for the same effect.
Yep. I can do that if I wanted to. But I do want to step through this in the debugger really quickly just to solidify this for anybody who's wondering what's going on. Okay, so let's go ahead and have our index variable. We'll notice it gets initialized to 0, and we loop 10 times until this condition is finished. So now if we jump to the end of that loop, if we open up our for loop, let's go ahead and put our I over to the side. If we look at the I, we'll notice it's an uninitialized variable. And if we hit F10, you'll notice it becomes initialized to 0. What actually happened here was the I variable got initialized to 0, and this condition got executed. And the condition is I is smaller than 10. Is 0 smaller than 10? Yes, it is. Then execution jumps into here. So that's important to know that this action only gets executed at the end of each loop iteration, which I can prove by hitting F10 one more time or twice, because now actually what's happening is the pointer is pointing to this line of code right now. Now if I hit F10 again, you'll notice I becomes 1. The index actually got incremented. So you'll notice that we continuously loop through until this condition right here becomes false.
I'm going to slightly paraphrase somebody's question.
Okay.
Once that window goes away. What happened if on line... You going to leave it still? Marvellous. What would happen on line 15 if you had ++i at the end instead of I++?
Nothing. Exact same behavior.
Why? The actual question that came in was, what is the difference between ++i and I++?
Those are the post and pre-increment operators. The difference between the two is that within the context of an expression, I++ will happen after the expression has been evaluated, whereas ++i will happen before the expression is evaluated. So for example, if I were to have int ble, and I were to see out ble++, and then I was to see out ++ble, what we'll get is a little interesting. We'll get 1. Wait a sec, I can't even read that.
That it's just because you didn't have a new line.
We get 1 followed by 2. And that's actually kind of not what I was going for. Let me break these out into different expressions. Because as we learned before, the behavior of this actually wasn't defined.
There you go, 0, 2. See, that's what I kind of expected that to happen in the for loop with the prefix operator. It skips directly from 0 to
the action
2.
Always happens at the end of the iteration. It never will happen before. So what happens here is this kind of demonstrates the difference between the postfix and the prefix increment operator, where the postfix operator will say, okay, when you're done evaluating this expression, increment ble by 1. The prefix operator will say, when you get to this line right here, increment ble by 1 and then use it in the expression. So as a result, we get 0 on the first line because ble is 0, and it doesn't get incremented until it's already passed into cout. And then on line 10, because ble is now 1, because it's been incremented after the cout call, we get it incremented again because this happens before the cout call, and we get a 2 being printed out.
It'd be even clearer if you swap the 2 over, actually, 9 and 10.
What?
If you swap lines 9 and 10.
Yeah, we get 1 and 1. Okay. Any questions about for loops? They're really that simple.
Someone did ask if the float version of the loop could mess up due to floating point error.
I doubt it. The reason I doubt it is because 0.1 float is such a small number. It has a really close precision. It only has 1 significant digit in it. It's very unlikely that adding only 1 significant digit into a float is going to cause a floating point error.
Did you see Harvard's question there?
Is there any advantage of using for as an influence instead of while true? The only advantage that I see is the question is, while true, like what we've talked before, is an infinite loop. It's never going to terminate.
Yeah.
This
You can't.
what?
I was just saying, surely you can't use it for an infinite loop because you have to provide the stop signal.
No.
Or could you just put true in there?
This is valid.
Ooh.
You're not required to provide any of the three parts into a for loop. This is valid and will result in an infinite loop. The only difference between these two, in my opinion, is the fact that this is a lot clearer as far as its intention. When would I use a while loop over a for loop? I would use a for loop for every single range that I might want to represent. If I wanted to represent the range between x to x by x, so if I wanted to represent the range from 0 to 100 by 25, I would definitely use a for loop because it's a lot clearer syntax. I would use a while loop when I don't need to necessarily perform an action or necessarily to declare an additional variable.
Pretty much any time at this level of programming, you can think about it in terms of how you would say it in a sentence. If you want to do something while something is true, you use a while loop. If you want to do something for a set number of times, you use a for loop. If you want to do something for each thing in a group, you would do something we haven't covered yet.
Yeah. I have to sign for something.
Let's go ahead and take let's go ahead and take a 10-minute break, Nelson. Hey. Or not.
He's got to answer the door.
Well, let him answer the door real quick. I'm going to hit pause. Welcome back, ladies and gentlemen. We're now resuming from our break. Nelson, continue.
Okay, so are there any more questions about for loops? They're not that exciting, but they're very useful. Okay, just because we haven't had anybody type anything out really, because this has just been mostly a lesson about here's how you do this. Now I do have an actual problem that I want people to solve.
Woo, problems.
So
I said, woo, problems. I like when you pass out problems. You get people involved. That's good.
Okay, I want people to write a C++ program that uses a for loop that starts at 100 and prints out the values of 100 to 0, or how about 100 to negative 100 backwards by 25.
Forwards.
Show them that out.
Forwards.
Show them what you expected to print.
I like how you.
Well,
I really like how you.
You want to see 100.
Hang on, Gavin. Yeah, he's going to write it out. I really like how you specified the backwards. No, we could have gone forwards, I guess.
Yeah, you could actually.
I know, that's what I'm saying. I guess.
This is what I want being printed out using a for loop. Ready, set, go. And this is particularly geared towards the absolute beginners to programming, because I know we spent a lot of time going over relatively advanced things in this class so far, just because to do some simple things requires some advanced concepts. But I really want the people who are new to programming to go ahead and print this out. And just out of curiosity, how many people who are completely new to programming have been following along and are actually still here?
All right, so we've got 3 people that are now done. Paste your code over in the questions panel. Paste your loop over in the questions panel. Go.
Okay, we're still holding on to some complete beginners, so I'm happy. And you guys are following along all right?
And if you're not, please ask questions. Gavin, I'm sorry to clutter up your questions panel. I like seeing people throw in their answers over there.
No. I wonder if we should pause, because there's still a lot of people who are participating who are not ready.
Ladies and gentlemen, we're pausing right now. And we're now back to your regularly scheduled C++ Week 3 program. Nelson?
Yeah. I do want to point out just one quick thing. NATO, please, what error are you getting when you build? And then we'll address that. Okay, so the way to do this would be to go for int I equals 100, because we start off with 100. Then we say I is greater than or equal to negative 100, because we want to print until we reach negative 100. Then we want to decrement I by 25, which we could either do this syntax right here, or we could say I minus equals 25. And now when we see out, we'll get the output we expected.
Have you got all your includes, Chris?
I don't know about that extra comma, though.
Namespace.
Nelson, I think you failed, actually. Don't sigh at me. What's wrong with you? I'm just saying, you gave an output and you failed.
And that's really hard.
Much better.
Actually, the best way to do this, the way I generally prefer to do it, is just to do if I is smaller than 100, then prefix it with that. I'll generally do that instead. Just the opposite. I find that to be cleaner, especially when working with zeros and especially when you're working with a range that's calculated and you start with a 0. By saying, and you're incrementing up, saying I is greater than 0, and then doing a prefix of the comma will generally be cleaner.
Now let's check with NATO and see what blew up over there real quick.
Unresolved external symbol main. Do you not have a main function? Because you're going to need a main function.
And check your capitalization of main as well.
Yep.
I think I've had my my mute switch flipped the opposite way to what I thought it was. So I've been muting every time I want to talk.
You did seem unusually quiet.
I was like, why is Buzz saying that? I just said that.
Because Buzz didn't hear you.
I can never tell if you guys are actually ignoring me or if I'm on mute sometimes. It's very sad.
Like that one night you were on mute for like half an hour.
That was funny. You sounded so
sad.
Sad afterwards. Yes, melancholy. I was going for.
No, yeah, the Pierce.
Well, actually, no. It's good because that's a good sign you've done that because you're used to doing it for methods in C#.
Right.
All right, sweet.
Wolf asks, what's up with this? What this does is this conditionally prints a comma if we are past the first item in what we're printing. So it checks to see, are we past the first item that we're printing, then print a comma. And that'll give us the output like this. If we did not have that condition in there, there would have been a comma at the beginning of every single number. If we had the comma being printed after the number, then there would have been a comma after the last number, which doesn't technically match my expected output. Alrighty. So any more for loop questions? Because we're now about to get into range-based loops, which is going to be kind of fun. And when I say fun, I'm being sarcastic.
And I am going to say that it's not the end of the world if you cannot do it on your compiler.
Yep.
Is this a VS 2011 only? 2012 only?
Okay,
yeah,
so let's talk about range-based for loops.
We're getting into something that's C++ 11 that's not supported on all compilers yet.
If people here are familiar with C# for each loops and how they work behind the scenes, you'll be glad to hear that C++ 11 did introduce something similar. Range-based loops look like this. That being said, they are not supported by the Visual Studio 2010 compiler, sadly. So let's go ahead and jump over into the other, for some reason, my Windows 8 paused.
So is there no such thing as a for each loop then?
No, not in C++. There is this. This is a for each loop, actually.
Yeah, I can see what it's doing. It's very similar to the Python syntax.
Oh, come on. Oh, this is just a sick joke.
Well, you see, this is what happens when they try to use a touchscreen interface for a PC, you see.
Alrighty, so now I'm in Windows 8 land with Visual Studio 2000. Well, I already have an example up here. Visual Studio 2012. So let's go ahead and talk about how we can use, and by the way, I really like Visual Studio 2012. Now, a range-based loop is going to be it's going to have some issues with this, and I'll show you what I mean by that. The IntelliSense for Visual Studio 2012 beta does not support range-based loops, so you will get IntelliSense errors. So what's going to happen here is that when I hit F5, although we have some squigglies, we will get a successful build. And it's going to build and print out what we expected it to.
And the squigglies have gone away.
They're going to come back once I jump back in. So I do want to point out that, that you will get this. But this doesn't necessarily require a whole lot of explanation because all we're doing is we're looping through an array. Now, I want to point out to people who understand what I'm about to say that range-based loops will also work on objects that define a begin and end method. So, for example, now that we've talked about strings, we can talk about their begin and end methods. If I wanted to loop through all the characters of the string, one of the ways I can do that is say for auto I equals meister.begin, I does not equal meister.end, I++. And then I can say inside of here, now this syntax right here, don't worry about it. This isn't an actual pointer dereferencing. This is a specially overloaded operator for what's called an iterator. An iterator object allows us to go walk through all of the items inside of an iterator or inside of a collection. Now we know that Meister is a collection because it supports the begin and end methods. This actually expands out into string iterator I, but I'm using the auto here because it looks nicer. So what this is doing is saying, give me an iterator that starts at my string. Stop the loop or continue the loop until we get to the end of the iterator, and then move the iterator forward on every iteration. This is very similar to the IEnumerable in C#. So if I were to go ahead and run this program, what we'll get is every single character of the string printed out on its own line. The range-based looping supports the concept of begin and end, meaning for all the collection types in the C++ and collection types we define ourselves, we can iterate over all the items within that collection using range-based loops. So we can say for auto ch in Meister, we could say cout ch new line. And again, we do get the IntelliSense errors, but when we compile, it successfully prints out hello world. Essentially what's going on here is this code is turning into this code. Andrew asks, are begin and end defined as an abstract class? And the answer is no. Begin and end are simply conventions that are used in all of C++'s collections. This will work with VS 2012 no matter the operating system we're using. So this will work in 7 or Vista if you have VS 2012 installed. I do want to point out that this code right here is perfectly valid in Visual Studio 2010, and well, every version of the compiler that supports implicit typing. But this is what's the new feature. Any questions about range-based looping before I jump into Ubuntu and show people how to enable this feature within Ubuntu with GCC? Any questions? Come on, this is the C++ 11 stuff that everybody was so stoked about.
Woo.
Yay.
Yeah, that's what I said. Woo.
Yeah. Does the for each have the possibility in causing problems of crashing if an object in an array is moved? I can't remember. Okay, well, we do get a nice little debug assertion, which I presume will not be the case if we run this in release mode. Yeah. So yes, we can modify the collection during iteration, which makes me sad.
So that's a Lego.
I've just never tried to do that before because it's not something you would ever want to do. Since we're talking about for each loops, IntelliSense tab complete for each into for each object. That's actually what?
You know how you said there wasn't a for each in C++?
That's not C++. That must be C++ CLR. Let's verify that really quickly. That has to be an extension that Microsoft added.
Just to mess with your head.
Yeah. Yep, this is an extension. So I can say for each object var in args. And it does it compile? Well, actually, hold on. We have to do system string. Yep. This is, if you see this syntax, this is an extension Microsoft added to C++ CLI for compatibility with .NET. It's not something that we care about in this class. Okay.
Yes, it is, Savannah.
Let me jump over into Ubuntu before something else gets printed in there that I didn't intend to.
That was pretty funny.
But that was... Alrighty. So to answer that question, yeah, the problem with it was that that's a C++ CLR feature that happens to be a template that you can use. Okay. Since we were talking about for each loops, what does the new IntelliSense for C++ look like? Just what I've been showing before. So let me jump over to Windows 8. And the IntelliSense just looks like this. Same thing, different icons. but it works a whole lot better. Okay, what's the colon operator called? This operator is called the namespace resolution operator. It resolves namespaces and static members of classes. And we'll go over that a little bit more once we start talking about, well, more namespaces and static members. Scope resolution. Yeah, that's Segfault pointed out. That's the scope resolution operator. Why would I use this? I don't see how I would. Well, using the it's just way cleaner. Not only is it way cleaner, once we start talking about the vector class and other classes that we can iterate over, there's some really fun stuff we can do with the vector class and other iterators. In fact, we can get functionality similar to that of link in C# by combining a variety of C++11 features.
And Harvard points out there's a for each if you include the algorithm.
Yes, there is a for each function included in algorithm. Yes, but it's really ugly. I mean, let me go ahead and substantiate that, and everybody's going to agree. Actually, that's only going to work with a string. So I believe that's the syntax. Yep. And look how readable and clean that is compared to So yes, there is a for each defined in algorithm, but the for loop is preferable. Also, what's so ugly? This is ugly. But we'll talk about that at some point, not today. I just wanted to point out that yes, there is a for each construct, and it does take in a functor, which you can pass a lambda in as, but it's not necessarily the prettiest thing on the planet compared to the new built-in syntax, which is significantly preferable. Okay, I did get a question about what the, and I guess I have to answer that now that I've opened up this can of worms. I got a question what this meant right here. This is basically saying, give me the current item out of the iterator that we're pointing at. What are those uppercase arrow stuff? I'm not sure what you're referring to.
That was in the extension method.
Ooh.
You add the upwards, the circumflex.
This thing?
Yeah.
This is an extension that Microsoft added for C++ CLI. It's used to reference a .NET object. It's not something that we're going to be talking about a lot or at all. Just know that it's part of C++ CLI. Okay. Does setting VS11 to native only remove using CLI? Because when I have it set to native only, I can still use for each. The way that you enable actually, we don't have that template here. So he's saying that he can still use this inside. So let's say we char in my stir. Okay, it does look like this is available within the native Visual C++ 11. I want to point out, though, again, that's not valid That's not going to be standard compliant C++. If I go down to a particular option called, where are you?
Platform toolset?
No, there's an option to enable or disable compiler extensions.
There was something on the general that said no runtime, no runtime. Where is it? Use standard Windows libraries, blah, down there.
No, that's not it. Okay, I can't find that option right now, but I did see an option to disallow compiler extensions.
But presumably, if you were to use that for each format there, when it's compiled, it will turn into the same thing it should do.
Yes. However, it's not going to be compatible with stuff like this. I can't say for each char ch in stir in GCC because it's not a platform. It's not something you would ever want to use, period, anyway, because it's just a extension that Microsoft added to the Visual C++ compiler.
Well, it seems like they added it for me, for the C# user who would immediately go for each this in that.
Yep.
Excellent.
But it's not something you want to do. Instead, you would want to use the new range-based.
I really don't.
But you do. Because that's platform compliant or standard compliant. Okay, and the project was made with Win32, yeah. Again, it's just a extension that we don't care about. So we're going to use this later. Will we need to get VS 2012 beta to use it? I would say yes if you want to use it, but it's not going to be required for use.
Right.
It's something that you can use if you have the compiler.
So anything more on...
I don't think so. I think we need to go ahead and move on over to switches now.
Okay, I do want to point out really quickly, though, the way I got this to work instead of GCC is you have to pass a special compiler flag. And that compiler flag is -std equals C++ 0x. That is the compiler flag you have to pass into GCC to support the range-based looping. Okay, switches. Go back on it.
Which bit didn't you understand?
Yeah, if you're using CDT, right-click on your project, go down to Properties. On the left, go down to C Build. Go to, I believe it's Settings. Oh no, it's not. It's under. It is under Settings, and then go down to Miscellaneous, and then add -std equals C++ 0x. to the compiler flag to let you use that feature.
And Wolf, yeah, you can use it if you can use it in. He's teaching it because it's usable. It's just obviously if you're using what is now an older version of the software, it's not there.
Well, the bottom line is we're in a transition period.
Yeah.
C++ 11 is the new C++, and it is what we are using. I mean,
is it a release candidate yet, or is it?
No, it's standardized as far as I'm aware.
Yeah, C++ 11? No, I thought it was standardized. It's just not all of the...
Sorry, I meant Visual Studio 2012. In order to run.
No, it's beta. But it has a Go Live license, meaning it has a production level license attached to it. Meaning that Microsoft is confident enough that it's good enough to use and stable enough to use.
Right. I would much rather people be introduced to this, since this is something that is, well, has become standardized and will be seen more and more. It's not something we're going to require in homework, though.
Right. It's going to be something that you can use if you want to, and if you have the compiler. Okay. Switches. Switches are simple. Let's say we wanted to, I don't know.
So that's between 1 and 24, yes?
1 and 4?
Sorry. Well, I read it as enter a number between 1 and 4 bang, which is between 1 and 24.
Oh. Okay, so now we have, basically what we've done is we have defined a switch block. And the switch block syntax is very simple. We have a switch block followed by a value. And that value is going to be any variable that we have in our program defined at this point. Then in... Do what?
Isn't your indentation off?
No, this is how it's indented with Visual Studio or Visual C++ by default.
Oh. Sorry, carry on.
Okay, so in C++ it would look like this, or C# would look like that, but by the default. To be honest, I kind of like this more. Okay, so what a switch block does is it's going to go ahead and allow us to add these case statements. And these case statements are going to match with equality whether or not this value equals the expression that was passed into the switch statement. So we have case of 1, case of 2, case of 3, case of 4, and the default case, which will be executed if things did not match any of these previous case statements. Inside of the case statements, we have a block of code that gets executed if one of these things are true, followed by a break, and the break exits out of the switch statement.
And this is exactly equivalent to a whole string of if else, if else, if else, and a final else.
Yep. I mean, I don't know how much more explanation we'll be needing. It's not in a loop. This isn't a loop. The break right here has no correlation to the break that we're going to be talking to, or talking to. Yes. The break we're going to be talking about in a moment here. You can pass in whatever you want into the switch. So I can pass in string literal or, never mind, it has to have an integral or enumeration type. So that's going to be an integer, float, Boolean, double, character, and so on. So if I passed in A, which has an integer type, I can say A, B, C, D, for example. Switches do not support ranges, but they do support what's called falling through. So for example, if I wanted the same thing to happen if they switched on 1 or 2, then I can simply say case 1 and then case 2 right next to each other. So I'm just adding multiple case statements to this one condition.
And in fact, could you actually make it so that you entered choice? Woo.
Yeah, I could do that if I wanted to. So for 4, I get the sad face, but for 1 through 2, I get you entered blah woo. Are you saying we can use the new Visual Studio for the course? Been itching to use it? Yes. You are more than welcome to. So the answer is no, switches do not support ranges. All right, any questions about switches? They're kind of boring, but they can provide some nice looking syntax in certain cases. One of the most common things I might do is maybe string product name. I might say switch on choice, and then I'll write code like this. I'll say case 1 product name equals product 1, and then do a break right there. So that's commonly how I'll write a switch statement if I ever end up using one. Can you leave off break to make it a loop? No. If you leave off break, it's simply going to fall through. Meaning if I type in 1, I'll get this line will execute, and then this line will execute. So the break has nothing to do with it being a loop. I heard you didn't like switches. Is this true? Why? Because I generally prefer, in cases that I have a variety of conditions I want to test, I will generally just use if statements. And the reason is if statements are more powerful than switch statements, because with if statements I can do ranges or any kind of executable code inside of them. Switches have a lot of constraints on them. They're very. You what?
I was going to say, if you do it with ifs, rather, one thing you can't do with the switch is have 2 of the cases happen, if they're both true, which you can do with variety of ifs.
2 of the cases.
So, yeah. So if choice had a 1 and a 3, you couldn't have case 1 and case 3 fire.
Yeah. You're very limited with switches, so I generally don't use them.
I have a slightly different perspective on switches, which is I really like them. But the point being that that's only slightly different. But I like them because they limit you in that way. They work very well with enums. Anything where you know you've got a finite set of options, they work very well switching between them. For the exact same reasons that Nelson just explained why he doesn't like them.
Okay. Somebody else asks, are practical examples of using continue and switch statements? I just want to point out one more time that the break and continue listed in the syllabus are break and continues for looping. Switches have nothing to do with looping. The fact that there is the keyword break used inside of a switch statement has no correlation whatsoever to the concept of looping. And if you were to use a continue inside of a switch statement, that would have no meaning to the switch statement itself. Now, it might have meaning to the encasing loop, but it doesn't have meaning to switch itself. Break and continue are different concepts than the break being used within the switch syntax. Okay, so are there any more questions about? Could you show the first example again? So something like. Something like that.
Have you ever seen continuing switch statements in C#?
Never.
No.
Well, yes, sometimes, but only if it's enclosed in a loop, and the continue had nothing to do with the switch statement. It was just a, yeah. Okay. Alrighty, sweet. So I'm going to assume that everybody's good with switches. So let's go ahead and talk about break and continue. What does break and continue do? Well, break and continue in the context of a loop allows you to break the loop or continue executing the loop. So for example, we could say while true, enter, I don't know, about enter 0 to exit loop. And then we can say int choice, cin choice, if choice is 0, then break. So now we can continuously type in things that aren't 0 until we type in 0. And that will break the loop. Breaking the loop simply means we exit out of the loop no matter if the condition is true or false.
Ironically, you can reverse the direction of your if to show the continue.
Yeah, I can say cout you entered choice, and then I can say if choice equals 4, because I hate 4 so much, we can say continue. I do have a question. In choice, do not assign to 0, otherwise rubbish. The only reason I'm not assigning this to a default value is because I'm immediately turning around and using it for input. Adding in the equals 0 here will just add in a pointless instruction that does nothing to the program's stability or correctness.
I imagine you covered this and I just blinked and missed it, but it's not possible to do cin into int choice all as one line?
No.
Okay, cool. So finish explaining.
Okay, so what's happening here is now we have an example of a break and a continue. So we can continuously type in things, and it'll tell us what we... That's horrible formatting. We can continuously type in things into the loop, and if we type in 4, it doesn't execute line 23 because we've effectively skipped over it. So you'll notice if I go ahead and put a debug in here, and I type in 4 as the choice, what's going to happen is execution is going to go into line 20, which is this continue right here. But when I hit F10, we're going to jump all the way back to the beginning of the loop. So a continue will just continue the loop from the condition. A break will terminate the loop.
It's a key thing to understand the difference between the two of those. Well, I always think between break, continue, and return, to be honest. I was very fuzzy for quite a long time on which did what of why.
It would be good to mention that you don't need the curlies for the if. You don't need the curlies for either of these ifs, but I normally wouldn't put them in. But when you get into nested if statements and else statements, not putting in curlies will lead to strange behaviors. And if you're not used to seeing that sort of syntax, you will get very confused very quickly. So I'm recommending that anybody completely new to programming to put in the curlies. But if you are comfortable not putting in the curlies, you're more than welcome to not put them in.
Yes, essentially, if you already know how and when to not put them in, that's fine. I will not have a problem with that being done in homework. I'd just like to point that out now to avoid the many messages. But yeah, if you're new to it, just for now, leave them in all the time for your own clarity and sanity.
Yeah. Okay. Can we use continue in week 2 homework? It's up to Gav.
Yeah. Anything like this, but you will be held responsible for using it correctly is the key thing. So at this point, anything that's been shown up till now is fine. There has actually been a lot of discussion on the forums. Very briefly, I would just say that somebody nailed it down. They said there's too much focus on the letter of the law. The idea is to get you to do things that you understand, and and to make sure also that you understand the things you're using. And for instance, there are like occasions where using a while loop isn't going to be the right choice. A lot of the time, you would use a for. But doing things with the while loop really makes you understand the while loop.
Right.
And the only reason I really stressed it so heavily was in the first week of the C# class, I did have some submissions that were pages and pages and pages long of very interesting and entertaining stuff that I blinked and then went, right, that's correct. There's no point in you spending hours and hours producing the most beautiful work of art ever if I'm just checking whether or not you can use ifs, whiles, and fors. End of advertisement.
Okay, how do you break through nested loops? The best way to break out of a nested loop, let's say we have for int I equals 0, I smaller than 10, I plus plus, and then perhaps for int j equals 0, j smaller than 10, j plus plus. How would I break out from both of these? What I would do is I would set a Boolean variable called exit up here, And then inside of here, if I say, let's say if I equals 4 and j equals 2, then I would say exit equals true and break. And then down here, I would say if exit break. Now, if I put a cout right here, I would go ahead and do this. So you'll notice that we get to 4.1, and then everything terminates. So is everybody good on nested loops being broken out of? Now, if you do this, I'll be very upset.
Sorry, what did you do?
Gavin.
Oh, that, yeah. Sorry, I wasn't looking at the screen. I was reading I was trying to work out what somebody meant. Yeah, don't use goto ever. Unless you're like visiting from about 1979 in a time machine that you've invented. In which case we'll talk.
All right, are there any other questions?
Because it's evil.
I know goto is very bad. Why is it still in C++? Well, to answer that question, it's the same answer for why is I don't know.
Why is phonetically not spelt phonetically?
Why is
Because it always wasn't. And there's still some programmers around that haven't retired that learned to use goto. Is probably the answer.
I think, yeah. The answer to that is the same answer to why is this still valid C++ code. The reason this is still valid C++ code is this is how you define structures in C. Even though they introduced a better way to write this code in C++, they can't remove it because it would break backwards compatibility with C and make a bunch of existing code break. So if they were to remove gotos from C++, then a lot of existing code would break and people would be very upset and they wouldn't use C++ anymore. The reason C++ 11 took so long to put together was because they needed to make all the features work with creating as few incompatibility issues as possible. Now remember that even in C# we still have some cruft from old versions of C#, like the non-generic IEnumerable, for example. And all that stuff's just garbage that's been around since C# 1. Remember, C#'s only been around for like, what, 12 years, 11 years? C++ has been around since, what, the 70s or 80s? So it has a significant larger amount of cruft in the language that has existed and is going to continue to exist forever because C++ is not going away anytime soon.
And K73, yes, never, ever, not even to break double loops, never use gotos. Ever.
Yeah.
So any more, is that it and we're on to homework?
I guess.
Any more questions that relate to anything from today? Going.
Gone.
Wented. Cool. Homework. Homework?
Homework. Okay, so I assume that everybody here has been doing the or has done the vending machine, at least up to a point. I want it. let me go ahead and just make sure what I'm about to say is going to be compatible with the existing prompt. So give me 1 second. Okay, I want people to modify their vending machine. So
You can't do the vending machine.
Hmm?
Nothing.
I want to modify the vending machine. I want the at the beginning of the program, allow the user to enter, let's say, 4 product names and 4 prices. Or how about just 4 products, name and price. You do not need to support names with spaces in them, but you can. And you still do not need to worry about input validation. Rest of the program will continue to behave like before. And yeah, and now everybody is welcome to use any of the features that we have gone over today, which should make their code a lot cleaner. And now I do want to point out that this is going to be a very interesting problem to solve in C++ because you're going to have to create a string array and deal with the string array simultaneously with the price array.
And this is all still going to be in main, yes?
Yes.
This will all still be in main.
No, you cannot use structures.
Did BuzzNet blow up? Or is there still text in there scrolling by?
Oh no, it's blown up.
Okay.
It blew up.
And to answer the question about will I get this video up, of course I will. It'll be up tonight, along with the UDK video. Well, I just saw your little piece come through, Nelson, but it ate everything I typed in there.
No custom functions yet? No. We're going to go over functions next time. And actually, Jason, I just had a horrible idea.
A horrible or an awesome idea?
You want to hear my horrible idea?
Your awesome idea? Shoot.
How much would you like to see after the user has entered all the products, how much would you like to see the selection menu being sorted by price?
Ooh. I like it, actually. And you know why I like it.
I know why you like it. There's an S after the A in ascending, before the C.
S after the A. I can do better than that.
We could, but
is that a challenge?
No, Nelson. He's been through everything we've done C++. We have people in the class that truly are absolute beginners.
We could have them make a little ray tracing application.
That'd be fun. Actually, that'd be a lot of fun.
Addressing Joshua's question, do you want a separate version of our program without this mod? Well, yes, that would be week 2's homework. This is week 3's homework. And there wasn't a week 1 homework.
Because that would have been crazy. Would have been like 1,500 homework assignments.
Well, actually, I'm into 3 figures in the number of Dropbox requests for C++ homework.
Oh, nice. Nice.
Should we keep the products we had in our program? No, it should all be entered by the user. I really want to see people try to use strings, and I know that people, especially people new to programming, are going to probably be banging their head against the wall with using strings and inputting from the user. and that's definitely something that's going to be a very valuable learning experience.
I want a booble sort.
You want a booble sort?
It sounds really cool. Is your life bothered with unsorted boobles? No, don't apologize. I thought that was hilarious.
No. Well, I don't really want to accept functions because I want people to do, even if they know what functions are, I want them to feel the pain of not having functions.
This all goes on in main. The end.
Feel the pain.
Really, yes.
All right, so is that about...
And that's actually... It's a running theme. Again, I just want to reiterate, this whole thing is a running theme in all of our classes, and I think it's very important for people to use things...
We're sadists?
Well, no. Well, maybe. To use things to try to solve problems with fewer tools so that the tools that we go over have more of a context, which makes going over the next lesson easier for us. Because the number one question that everybody has, no matter what feature I introduce of anything, and it doesn't matter if it's objects, it doesn't matter if it's classes, it doesn't matter if it's templates, it doesn't matter if it's anything. In fact, a lot of things we've introduced thus far, number one question is, why? Why do I want to use this? I don't want to use this. I mean, it doesn't make sense to me. I don't see how this is beneficial. So I really try to structure the homework in such a way that people are forced to solve a problem in a relatively painful manner so that when we introduce a new concept, they say, oh, okay, that would have saved me, an hour of working this problem out. Or that would have saved me 50 lines of code. Or that makes this more robust.
But also, it's like in any subject that you study to any level, you will at some point cover the history of that subject. I studied music. I was studying Baroque music. I was studying music from the 15th, 16th century, despite the fact that I'm a saxophone player, and thus there wasn't anything written for it before 1851 when it was invented. But you still study the history, and this is like a potted history of the development of programming languages in general. You started out with go-tos and line numbers that you had to type in by hand. And people started saying, well, hang on, look, there's better ways of doing this. And this is why things we've split up into C# and C++ and blah-de-blah.
And I just wanted to say real quick, Florin, make sure that you don't have any browser tabs, windows, anything open with BuzzNet on it. If so, completely kill out all your browsers, relaunch a new one, and go to BuzzNet. And David, to pass the course, you need to successfully complete all of the homeworks. But if you turn a homework in that's failing, you'll be notified about that. You'll have an opportunity to get it corrected and submit it again. So it's not like it'll be the end of the world. I just wanted to say those two things. And homework will be found up over in the forums, and Gavin will get that posted
soon after this. Yeah,
and the link.
I'll be doing that
and
tonight.
I will get the video encoded and put up for you guys. How fast are we notified? As soon as Gavin can get to it. If there's a problem, again, that's if there's a problem with the homework. If you don't hear anything at all, then good job.
At no point will anyone be notified of anything before the homework deadline. Just to point that out, which obviously is Wednesday for the first week's homework, and will be the following Wednesday for this week's. It's the one problem with having classes at both ends of the week, which is, well, it's not a problem. But however much time I give to the Friday class, the Monday class is always going to get 5 days more. That's just how time works, I'm afraid. There's not a lot we can do about that. And it does cause the homeworks to overlap slightly. So, sorry, but there it is.
Okay, so I guess that's going to pretty much wrap things up for today. Unless there's anything else either of you two would like to add in.
No.
Okie dokie.
Not that I can think
for
of.
For those of you that are going to be joining Zach here shortly with the UDK class, now's a really good time to go take a good 20-minute break or so.
Actually, one thing which I will say is just a reminder, I'm sure you all have, but if you haven't yet try to get your Dropbox set up. Obviously, you'll need to do that, and don't leave it until half an hour before the deadline, and then send me a PM, because in all likelihood, that will do you no favours, because I will be doing I will be making sure that they are set up in advance of the deadline. I'm doing them once a day in batches.
Awesome. Okay, guys. Well, that's going to wrap things up. Next Monday, class will be without me, so you guys don't give Nelson a hard time. And then I will be back. I guess it is next Wednesday when I return back. So you guys all have a wonderful week. Yeah. What was that?
You're seeing Tara Strong, right? I just got reminded of that for some reason, just out of the blue.
What's that?
Tara Strong is going to be in Calgary.
Yeah, at the Comic-Con thing? Yeah.
Yeah.
Don't close that, Nelson.
Yeah, no, he's going to need that.
Until you've copied and pasted it into Skype for me.
I'm idly resizing a window, which is what I do.
Thank you very much, Mr. Vokus. Comic-Con should
I'm
be
jealous.
awesome. I'm sorry, Nelly. As for everyone else, you guys have a good evening. We'll see you guys shortly in the next UDK class. Goodbye, all.
See ya.
Bye.